Welcome back, student. Now, today we'll discuss on refrigerant. As we discussed in the previous lecture video, that basically the refrigeration cycle, and in refrigeration cycle, basically there are four components or four devices are there. First of all was that compressor, second was the condenser, third one expansion valve, and fourth one is evaporators. So we already discussed on that what are the main function, and as you know that in case of different types of VCR component, what are the main function of each and individual component, and obviously when you calculate the performance and capacity of a VCR plant, that means COP. As you know that COP is the coefficient of performance, that is nothing but the ratio divided the ratio of the refrigerated effect, means net effect divided by net work done. So net effect means net refrigeration effect or refrigerated effect, that is basically Q2 in this diagram, and divided by W. Okay, so this up to we all know that. And what is 1 ton of refrigeration? That is 1 TR, actually 1 ton of refrigerations. Now in the previous lecture video we also discussed that what is refrigerant. Now as you know, as far as I know, that refrigerant is basically working fluid which works actually within the refrigeration cycle. So in the refrigeration cycle, the main working fluid is called actually refrigerant. But so what is its main function? So main function is it's act as a heat carrying medium. Okay, so main function is heat carrying medium, so which during the cycle in the refrigerator system absorb heat from a low temperature system and discharge heat to a high temperature reservoir. Now first of all, refrigerant means refrigerant, it's basically a heat carrying medium. Okay, fine. But where it is works, it works which during their cycle in the refrigerator system. Refrigerator system means, because as you know that in a refrigerator system there are main components are there. First process of compressor, second is condenser, third is expansion valve, and fourth one is evaporator. When the refrigerant or working fluid is flow through this component, or the thermodynamic process occur. Okay, so at this time actually they act as a heat carrying medium. How? Now heat carrying medium, it means when it goes through the evaporator, that means from low temperature reservoir, when it goes through the evaporator, it absorb heat from the low temperature reservoir by means of evaporator, and by means of condenser they reject heat to high temperature reservoir. So that is actually refrigerant. So main function is to act as a heat carrying medium which flows through the refrigerator system. That means system, as you know, there are four components, and that system actually produces a refrigerator system. When the heat carrying medium or refrigerant flows through this system, they act as a to absorb heat. The main function is to absorb heat from the low temperature reservoir by means of evaporator, as you know, and extract heat to the high temperature reservoir by means of condenser. So this is the main function of refrigerant. And at the first day of the VCR cycle, in the first day, or in the firstly, we use actually refrigerant like natural ice, add mixture of ice and water, salt. So these are the refrigerant that we can use in the first day of the refrigerant. Okay. Now, after all, when the days go on, the new refrigerant are formed, like the ammonia, carbon dioxide, ethane, sulfur dioxide, methyl chloride. So this type of refrigerant comes into the picture. But the main thing is that when the new refrigerant comes in, so there are some problem occur. What does the problem? The problem is that, as you know that the refrigerant should have thermal, chemical, and obviously for safety concerns. So thermal stability, chemical stability, as well for safety concern purpose actually. We should main three things have to look after. But as the refrigerant as the refrigerant comes into the picture, so there are some refrigerant is obsolete because uh, they have not actually the thermal as well as stability, chemical stability, as well as not safety concern. Means there are environmental hazards actually. Environmentally, they attack. So that's why some refrigerant already obsolete. Now the new refrigerant comes into the takes place. That refrigerant may be halocarbon, hydrocarbon type of refrigerant, which is actually used is nowadays in RS unit or refrigerant unit. So this type of refrigerant are used. But one more thing that, so there is no as such, no refrigerant are there that can be used, that can be used for all types of applications, because each and individual refrigerant has its actual advantage, some also disadvantage. So depending on your application, depending on your requirement, depending on your comfort zone, desirable or safety concern, chemical stability, thermal stability, you can use or you can choose yourself. You can choose actually refrigerant so that you can use easily and safely. Okay. Now we should have to know that what should be the desirable properties. What should be the main important thing, that what should be the desirable properties to select a refrigerant. So we can discuss on that. Okay. So these are the desirable properties of refrigerant. As you know that main 10 or 12 points are there. So that a refrigerant should have this property so that you can select it use as actually refrigerant. So first one is the low boiling and freezing point, and obviously the refrigerant should have low boiling and freezing point so that uh, it can actually use as a high temperature application, means within the compressor as well as means in the evaporator. So in high critical pressure and temperatures, so you should have. Second is high latent of vaporization. High latent of vaporization means, as you know that there are two types of heat are there, and one is sensible heat, another is latent heat. So sensible means latent heat are basically used for the heat is to heat to transform the phase, yeah, to transform the phases. So it is used for that. So it should have high latent of evaporation capability and low specific heat of liquid and high specific volume of vapor. Second is sorry, low specific volume of vapor, and next is high thermal conductivity, which is very important because, as you know, that when the refrigerant flows through the refrigeration cycle, so there is heat ignition takes place. Means when it goes to the compressor, when it goes to the condenser, when it goes to the expansion valve, when it goes to the evaporator, in each every cases there are heat transfer takes place. Means heat transfer, it may be heat absorb or heat reject, or it may be temperature increase or decrease. So thermal conductivity property should be high so that it can easily transfer heat. Okay. And non-corrosive in nature, which is very important because, as you know, in a refrigeration cycle is basically connected with some pipes. Okay, like from compressor to condenser, condenser to expansion valve to evaporator. So they are connected in between pipe. So this pipe actually, the pipe actually normally is in copper or like aluminum pipe are there, but this refrigerant should have non-corrosive. Otherwise, the refrigerant, if it is corrosive in properties, corrosion is properties, so they will react the pipe materials and they will get damaged. So non-corrosive in nature should be there, non-flammable, so that when the temperature increase in the compressor, refrigerant should have, if has flammable capability, if has flammability properties. Now after refrigerations, the temperature of vapor refrigerant is very high, as well as it can be up to, after a compression process actually, it can be reach up to superheated vapor refrigerant. So at that time the temperature is very high, so if has flammability properties of refrigerant actually, it can possible that it can burn out. So non-flammable properties should be there if it is to restrict flame burning out condition. Now second is non-explosive. So again, so low cost, obviously one important when you select a particular refrigerant, you can obviously choose your low cost but a good quality refrigerant so that you can accommodate your purposes. Second is easily and regularly available. So obviously, when easily and regularly available means stock is very high in the market. So obviously, regularly available means there is no problem at all to collect the refrigerant when you want to purchase it. Second is ozone friendly. So ozone friendly is important point in the concern of the environmental, because for the safety concern purpose, when you select a refrigerant, so it should have the ozone friendly properties, because as you know that ozone layer reduction, so they will react with the ozone layer. So after all, the environmental hazards will be occur, some environmental problems will be discontinued if the ozone friendliness is not there. So ozone friendliness is very important concern, because the refrigerant is basically component is consist of either carbon, hydrogen, nitrogen, or halocarbon types of material nowadays. So it should have ozone friendliness, and obviously the high COP. So high COP means, as you know, the coefficient of performance, which actually indicate the capacity or refrigerant effect that can produce. So obviously the COP should be high for the refrigerant, so that you can choose a refrigerant that you can suit your property, that you can choose your particular application. So these are the desirable properties. In this way you can choose your desirable properties to select a particular refrigerant. Now, as you know that what is refrigerant and what should be the desirable properties of refrigerant, now we have to know that what are the different types of refrigerant are there. So there are basically two types of refrigerant. One is primary refrigerant and the secondary refrigerant. And another way we can also define, or we can also classify the refrigerant. Okay. So these are refrigerants, and this is the classification of refrigerant actually. And as you know that refrigerant, basically there are two types of refrigerant are there. One is primary refrigerant and another is secondary refrigerant. Now, as the name suggests, the primary refrigerant, that means the refrigerant is primarily, and obviously, and indirectly also. So this refrigerant can be defined as which actually directly take part to cool, or to take actually take part in the refrigeration system. So main function is to take part in the refrigeration system directly. That's what is called primary refrigerant. And there are some others also, secondary refrigerant are there. Secondary refrigerant are those refrigerant uh, which are actually you can define actually the refrigerant which are firstly cooled by primary refrigerant and then used for cooling purposes. So first of all, we use primary refrigerant to cool in the refrigeration system, and then if you use another refrigerant to cool the system again or extra, then you can use a secondary refrigerant. So that's why it's called secondary. So primary and secondary. So depending on your working function, you can divide the refrigerant in two types, primary and secondary. So primary refrigerant, in which the refrigerant actually take part in the refrigeration system directly, and in case of secondary refrigerant, they actually act or part to take in a refrigeration system after primary refrigerant works. So this is the difference between primary refrigerant and secondary refrigerant. Now, as you know that generally the main, as in VCR cycle, the refrigerant basically which are used basically, that's basically primary refrigerant, because it directly take part in the refrigeration system. Now, depending on that, primary refrigerant can be divided into four categories. As you see that, first of all, organic refrigerant, azeotrope refrigerant, inorganic refrigerant, and hydrocarbon refrigerant. So first we'll discuss inorganic refrigerant. Now, inorganic refrigerant actually the first type of refrigerant which are basically used in the previous day of in the previous day when the diffusion system started. So the refrigerant actually has some lack in COP or chemical thermal stability. But this type of refrigerant we used, first of all, it is used like natural ice or natural ice plus salt plus water, like this type of solution is actually in as a refrigerant. But after those days, the refrigerant which is basically used, that is inorganic refrigerant. And this refrigerant, before introduce the halocarbon refrigerant, we can use inorganic refrigerant like ammonia, air, carbon dioxide, and sulfur dioxide, water. This type of refrigerant we can use in case of research cycle, and this refrigerant is called inorganic refrigerant. Now, if you discuss on halocarbon or organic refrigerant, uh, as you know that ASHARE. So there are indicate there are in our refrigerant in society, there are 42 indicated that there are 42 halocarbon refrigerant are there, but in between 42 halocarbon refrigerant there are lots of obsolete, actually obsolete because of their chemical and thermal stability, because less ozone friendliness, less safety purpose. Oh, okay. So these are the point that actually lots of refrigerant are obsolete from the list of the refrigerant of halocarbon. So, but in the context of halocarbon refrigerant, there are number is total 42, but actually in functioning is not 42. It's less than 42 number of halocarbon refrigerant. Okay. Now, it is basically ferron family of refrigerant, because main component in organic refrigerant is carbon, hydrogen, chlorine, and fluorine. So that is basically the ferron group of family of refrigerant, it is so called. And the first refrigerant which is basically used in case of refrigerant, in case of halocarbon refrigerant, that is R12. R12 is basically designation of refrigeration. We can discuss on the next lecture video. And because R suggests there are some refrigerant nomenclature, so there are some way that you can define or that you can design a particular refrigerant, which is the name. So R12, R11, R13, R14, R221, R221. So these are the types of refrigerant, actually organic refrigerant. So basically the first refrigerant that used, that is basically R12. Now the second refrigerant type of refrigerant, primary refrigerant, is that azeotrope refrigerant. So azeotrope refrigerant is the stable mixture of refrigerant whose vapor and liquid phase retain identical over a wide range of temperatures. So this is a mixture of two refrigerant whose mixture actually whose vapor and liquid phase are stable throughout the wide range of temperatures. So obviously the property should be increased, means of property means there are chemical, thermal, boiling point, their critical pressure, critical temperature, thermal conductivity. So all these properties actually refrigerant properties. So these properties can be enhanced because these are the two mixers, and more importantly point is that they actually they maintain the stable mixer throughout the wide range of temperature. This is the important point. As like adjective refrigerant is suggestively called R500. Again, we can tell that R500 is one type of refrigerant which can designated by refrigerant nomenclature. We can discuss on that. So basically this type of refrigerant mixture of two type of refrigerant is 73.8% R12 plus 26.2% R10. Okay. So R12 basically called CCl2F2. Okay. And is R12 is basically called CH3CHF2. So these are the adjective refrigerant, and another is hydrocarbon refrigerant, which are basically used in our industrial and commercial purposes, and which is very important in our industry scenario. And but mostly important point is that this type of refrigerant is basically highly explosive and flammable in nature, and as it is highly explosive and flammable in nature, so it kept or it is works is very safely. It should work actually in safely, so that no explosion takes place. Okay. And example of actually hydrocarbon refrigerant is that ethane, propane, methane, butane. These are the actually hydrocarbon refrigerant, because as you know that in case of ethane, propane, butane, so all these cases there are main hydrocarbon component of there, carbon and hydrogen. So that's why this type of refrigerant are called hydrocarbon refrigerant. Okay. Now the designation of refrigerant, as we discussed that what is refrigerant and what should be a desirable properties and classification of refrigerant. Now designation of refrigerant. Now how do you define or how do you designate the refrigerant? As we discussed that suppose that halogen organic refrigerant, that means, or halocarbon refrigerant, that is basically R11, R12, R13, R22, R21. So this type of refrigerant is designated by separately. How do you do this? So now look at the diagram. So this is the designation of refrigerant. As you know that for a compound which is basically saturated hydrocarbon, which is designated by CmHnFeClQ. Here, carbon, hydrogen, fluorine, and chlorine are main, as you know that main component of an energy refrigerant means for halocarbon refrigerant. So this is the component. So these are the compound which is basically derived from the saturated hydrocarbon. So saturated hydrocarbon basically designated with CmF, HnFeClQ, where N, N, P, Q are here, in which when it is saturated hydrocarbon, it should maintain that N plus P plus Q. So N plus P plus Q is equal to 2M plus 2. When it is saturated hydrocarbon, it should follows N plus P plus Q is equal to 2M plus 2. If it is not, if it is doesn't follow that N plus P plus Q is equal to 2M plus 2, then it would be unsaturated hydrocarbon. We cannot discuss on that. We will discuss on that. Now here, suppose the for saturated hydrocarbon, it should follows N plus P plus Q is equal to 2M plus 2. And for saturated hydrocarbon, for a compound basically derived from that formula will be, designation will be CmHnFeClQ, right? Now, suppose the name that is one refrigerant actually, that is dichlorotetrafluoroethane. Dichlorotetrafluoroethane, in which, as the name suggests, the dichlorotetrafluoro, substitute carbon atom, ethane. So ethane is C2H4, as you know, the carbon atom is 2. So here carbon is 2 atom, right? So because carbon is 2 atom means N is 2, right? And no hydrogen, so no, there is no hydrogen there. So no hydrogen means N is equal to 0. So here M is equal to 2, M2, N0, right? And fluorine means tetrafluoro. Tetrafluoro means 4. So fluoro means F. So P is equal to 4. Chlorine is 2 because chlorine is dichloro. Di means it indicates 2, number of 2 atoms. So chlorine, that is Q, is equal to 2. Now, you just check yourself that is it saturated hydrocarbon or it is unsaturated hydrocarbon. If you can N plus P plus Q is equal to 2M plus 2, then you can easily call it is a saturated hydrocarbon. Now let's check it out. So here N is basically H, no hydrogen, so N is 0, plus P is equal to 4 here, plus QCl, so Q is 2, right, is equal to 2M plus 2, 2 into M. M means number of carbon atoms, that is here 2, so 2 plus 2, 4 plus 2 is equal to 6, 2 into 2 plus 2 is equal to 6. So it is a saturated hydrocarbon, right? So obviously it should follow. Now, how should we define? The designation is that R defines the refrigerant. Capital R defines the refrigerant, right? Now R into M minus 1 in the bracket N plus 1 into, means not into actually, that is into dot P, right? So R M minus 1 N plus 1 P. So M minus 1 here, put these values M here. In this case of dichlorotetrafluoroethane, so M here, M will be, M is equal to 2, right? If M is equal to 2 means carbon atom is 2. So M 2 minus 1, N is equal to 0. So 0 plus 1, P value of P is here 4. So that's why it's 4. So 2 minus 1, 0 plus 1, 4. That will be R, that will be 1, 1, 4. Or it is also sometimes also called CFC 114, because the refrigerant constitute with carbon, fluorine and chlorine, right? So as in the same manner, you can also calculate or also designate the different refrigerant like CCl3F or CCl2F2. In this manner, you can do that if you put these values here, R into M minus 1, because M is here, okay, M is here 1, because carbon is methane here, carbon atom is 1, that's why M is equal to 1. You can put this here, N is equal to, because N is equal to here, so N is equal to 0, okay, because there is no hydrogen atom, right? CCl3F in this designation, in this refrigerant nomenclature, so there is no refrigerant, so N is equal to 0. P, what is P suggest? P suggests number of fluorine atoms, so F is here 1, so P is equal to 1. Similarly, we can write it as CCl3A as it is R11. In this similar fashion, CCl2F2, we can write here C is equal to 1, Cl2 means here Q is equal to 2, okay, and F2, 2 is equal to, you can check yourself, it will be obviously N plus P plus Q is equal to 2M plus 2. Then you can designate the refrigerant as R into M minus 1 into N plus 1 into P. Not actually into, but it is only applicable for saturated hydrocarbon. If you designate the refrigerant, if the refrigerant or hydrocarbon is saturated, then it can only possible to designate the refrigerant in this way: R into N minus 1 into N plus 1 into P. If it is unsaturated hydrocarbon, that means if it follows N plus P plus Q is equal to 2M, not 2M plus 2, here 2M, right? Now, if it is follows like that, suppose ethane, as you know that ethane is one type of refrigerant that is inorganic refrigerant, and it is obviously it is in use in commercial industrial applications, so, and it is highly explosive. Okay, so for ethane, if you want to designate the refrigerant, how to designate C2H4, so obviously it should follows N plus P plus Q is equal to 2M plus 2. So obviously it follows N plus P plus Q is equal to 2M. So it is unsaturated hydrocarbon. Okay. Now N is similarly same, because in this case also CM, HN, AP, CLQ. So in this case also both are same. N plus P plus Q is equal to 2M, right? Now, if this is an unsaturated hydrocarbon, then you can designate the refrigerant as R1 into M minus 1 into N plus 1 into, not into, actually P. So this is the designation of refrigerant for unsaturated hydrocarbon. And for saturated hydrocarbon, R into M minus 1 into N plus 1 into P. For unsaturated hydrocarbon, R1 M minus 1 N plus 1 P. Here R1 is here. Now, value of M means carbon atom, right? Because for ethane, carbon here 2. So that's why 2 minus 1 into N. Number of N means number of hydrogen atom. Here N is equal to 4. So 4 plus 1 P. What is P? P is equal to number of fluorine. Is there any fluorine atom is present? No. So there is no fluorine atom, that is will be 0. So after all R1, so it will be 1, this will be 5, and that will be 0. So the designation of refrigerant C2H4 will be R1150. So main two things is that the hydrocarbon, mainly refrigerant, are consist of basically hydrocarbon, and if the hydrocarbon is saturated hydrocarbon, so as you know that normal designation of refrigerant, that is CM, HN, Fe, ClQ. Now, if the hydrocarbon is the compound is derived from that CmHn, FeClQ, for saturated hydrocarbon, it will always follow that N plus P plus Q, where N, P, Q are the and number of atoms actually is equal to 2M plus 2. If it is saturated hydrocarbon, then only you can designate the refrigerant R into M minus 1 into N plus 1 into P in this way. Now, if it is an unsaturated hydrocarbon, that means if it is not follows this one, N plus P plus Q is equal to 2M plus 2, so it should follow N plus P plus Q is equal to 2M. Now, if it is follow these equations, means this formula, this condition, in so that you can only possible, so that you can able to actually designate the refrigerant by this manner. So R into 1, R not 1, R1, M minus 1, N plus 1, P, where M, N, P, Q are the number of atoms corresponding the carbon, hydrogen, fluorine, and chlorine. Okay. Okay, thank you very much. And in the next lecture video, we'll discuss on the VR cycle and the comparison between VR and VCR. Okay. Okay, thank you very much for listening and watching me, and goodbye.